Hello friends and my dear students, welcome back to my channel Phoenix Physics. Today we are going to learn energy and power in electrical circuit. What is energy? Energy is the capacity to do work. For example, I want to lift a 5 kg box from a floor. I require some amount of energy, no matter how quickly the box is picked up. So work and energy both are interrelated, having same unit, that is joule. Then what about power? Power is a measure of how rapidly work is done. That is, work done per unit time is nothing but power, and the unit for power is watt. In general, a source of energy is required to drive a current in a circuit. This current is provided by the battery. You know that battery converts chemical potential energy into electrical energy, and this energy is used to do work on the electron in a circuit. This is the general idea. Consider a circuit in which a battery of voltage V is connected to the resistor R. Here, when the battery is connected between the ends of the conductor, the current I is established. You know that battery gives electrical energy. So, battery is transporting energy to the circuit. When a positive charge dq moves from a point A to B through the battery and moves C to D through resistor and back to point A. When the charge dq moves from A to B, it gains potential energy. So, the potential energy is denoted by the letter U. It is nothing but dq into V. How do I write this equation? In our first lesson, we studied one formula, that is work done is equal to Q into V. Here V is potential difference, Q is charge. Instead of Q, I have dq charge. So dq into V. You know that work done is stored as a potential energy. That is why instead of W, I have written U. So U is equal to dq into V. This is my equation 1. At the same time, chemical potential energy of the battery decreases by the same amount. So two things occur in the battery. First one, it gains potential energy. At the same time, same amount of chemical potential energy of the battery decreases in the battery. When this charge dq moves from C to D through the resistor, it loses its potential energy due to the collision with the atoms in the resistor. At battery, it gains potential energy. At the resistor, it loses its potential energy. Our aim is to calculate power. What is electrical power? Electric power is the rate at which potential energy is delivered. Or we can write P is equal to du by dt. Substitute equation 1. So P is equal to d by dt of dq into V. Here V is constant, take it outside. So V into dq by dt. What is dq by dt? You know that current I is equal to Q by T. Suppose if you have very small amount of charge, means dq by dt is equal to I. So instead of dq by dt, you substitute I. The power P is equal to V into I. This is my equation 2. Here P is electrical power, then V is potential difference, I is current through the conductor. You know that SI unit of power is watt, or we can say joule second power minus 1. See, unit for work done is joule, time is second, so either you can write watt or joule per second or joule second power minus 1. Both are same. So power, SI unit of power is watt or joule second power minus 1. In our house we use various type of electrical bulb. So these are commercially available electrical bulb, that is 5 watt 220 volt, 30 watt 220 volt, 60 watt 220 volt. Here watt is nothing but power. Then what about 220 volt? This is AC voltage. If the voltage drop across the bulb is greater than the voltage rating, this is voltage rating. So if the voltage drop across the bulb is greater than the voltage rating, the bulb will fuse. Power formula is P is equal to VI. This is very important one. According to Ohm's law, V is equal to IR. Substitute V value in this equation. So P is equal to IR into I, that is I square R. Suppose I need current, means I is equal to V by R. Substitute V by R in this equation. So P is equal to V into V by R, that is V square by R. Totally 3 formulas for power P. P is equal to VI, P is equal to I square R, and P is equal to V square by R. These are very important one. Look at the second and third equation. Here I have I square R and here I have V square by R. If you double the current or voltage, the power P will increase by 4 times. See, for example, I is equal to 2 ampere. Substitute in this equation. So power P is equal to 4R. If you double the current, power will increase by 4 times. Same way, V is equal to 2 volt. Substitute in this equation. So P is equal to 4 by R. If you double the voltage, power will increase by 4 times. In our house, electricity bill is calculated in terms of units. What is unit? Unit refers electrical energy. How do you calculate this electrical energy? You know that power is equal to work done by time. Work done or energy, both are same. So P is equal to energy by time. Suppose I need E means P into T. This is our electrical energy. So practical unit of this energy is 1 unit. 1 unit is equal to 1 kilowatt hour. How do you calculate 1 kilowatt hour? 1 kilowatt has 1000 watt. 1 hour means 60 minutes 60 seconds. Multiply these 3. So 36 into 10 to the power of 5 joules, or we can say 3.6 into 10 to the power of 6 joule is equal to 1 kilowatt hour. 1 kilowatt hour is equal to 1 unit. This is the practical unit. In this class we derived the formula for power, that is P is equal to V into I. Using Ohm's law, we derived 2 more formulas, that is P is equal to I square R and P is equal to V square by R. Practical unit of electrical energy is 1 kilowatt hour. 1 kilowatt hour is equal to 3.6 into 10 to the power of 6 joule. I hope this video is useful to you. If you like my video, please share and subscribe my video. Thank you.